Hello everyone. So in the last video, in our last physics video, we looked at voltage, current and resistance and we related them through Ohm's law. And while we did do a few questions, the thing is that these questions get harder as we go. Before we just have to apply the formula and then get the answer, but now we have to apply the formula in multiple contexts and we have to combine series circuits with parallel circuits, and it's just a whole big mush. And so it's really important that we understand this concept. So in this video, we're going to be solving some pretty hard Ohm's law questions. We'll look at a few things that we should know and then we'll jump straight into the examples. So let's just get straight into it. Okay, so before we start solving the problem, we need to know a few key rules. In a series circuit, the voltage splits but the current remains the same. So if you want to calculate the total current in a series circuit, it would just be equal to any of the other currents. In voltage, because the voltage splits, you'd have to add all the voltages to calculate the total voltage in a series circuit. In the resistance, if you want to calculate the resistance, you're going to have to add all the resistance. Now, it's a bit different for parallel. In parallel, the current splits, but the voltage remains the same. So, if I want to find the total current, I'd have to add all the currents in the resistors in flowing through each wire. Now, if I want to calculate the voltage, since that remains the same, I can find any voltage and all the other voltages are going to be equal to that. Now there's a quite odd way of calculating the resistance. To calculate the resistance, I'd have the reciprocal of the total resistance is equal to the reciprocal of the first resistor plus the reciprocal of the second resistor and so on. But you may ask, why is this? Okay, let's find proof for this. So we can agree that the current splits. So another way we can write current is voltage over resistance. So voltage total over resistance total is equal to voltage 1, which is voltage total because voltage remains the same, right? So I can just write voltage total over resistance 1 plus voltage total over resistance 2. Now, what can I do over here? I can factorize the voltage totals out. So voltage total out, 1 over resistance total equals voltage total out, 1 over resistor 1 plus 1 over resistor 2. Now we divide both sides by voltage total, out, and this is how we get this proof for this. Okay, now let's do a problem. Okay, so this is our circuit and these are our problems. So let's solve them one by one. But before we do that, let's name our resistors. So let's call this resistor 1, this can be resistor 2, and this can be resistor 3. Okay, our first question is current flowing in each resistor. Okay, let's look at resistor 2. So first question, A, and we want to find the current flowing in each resistor. So current 2 for resistor 2 is 2 amps. Why? Because we can see the ammeter and the ammeter is telling us the current. Now let's look at current resistor 3. In this case, we know that voltage remains the same in a parallel circuit. So the current flowing through this area is going to be, through this wire is going to be 6 ohms multiplied by 2 amps, which is 12 volts. And if there's 12 volts flowing through this wire and the voltage remains the same in parallel circuits, there's going to be 12 volts in flowing through this wire. Okay, so current 3 equals voltage 3 over resistance 3. And how do we derive this? We derive this from voltage equals current times resistance. This is where we derive this from. Okay, current 3 should equal 12 volts over 3 ohms, which is 4 amps. Okay, so we know current flowing through the second resistor, current flowing through the third resistor. Now we need to find the current flowing through the first resistor. Okay, so we know that current splits when it goes in a parallel circuit. So if this is 2 amps and this is 4 amps, we know that it would have split right? So if we were to combine these again, we'd get 6 amps. So when the current is not split, there's 6 amps flowing through the wire. So the total current, so the current flowing through this resistor, which is in series, is going to be 2 amps plus 4 amps, which is going to be 6 amps. So that's the first question done. Let's look at the second question. Potential difference across each resistor. Okay, so what's the potential difference across each resistor? We can simply just use Ohm's law to figure this out. So in our first case, voltage 1 equals current 1 multiplied by resistor 1. So what's our resistance? 2 ohms. We already figured out the current, which is 6 amps. So voltage 1 would equal 6 amps multiplied by 2 ohms equals 12 volts. Let's apply the same rule for the second one. Voltage, this is Ohm's law. That means voltage 2 multiplied by current 2 equals resistance 2. Now, let's see. 6 ohms of resistance and 12 volts. We already know this. So we don't even need to do this because we used this to solve our last question. But anyway, we know it's a 6 ohm resistor and it's a 2 amp. That's what the ammeter is telling us. So voltage 2 equals the 2 amps multiplied by 6 ohms, which is 12 volts. And similar with this, we know the current flowing through here is 4 amps. That's what we found from the last question. And if we do the same, we get voltage 3 equals the 3 ohm resistance multiplied by the 4 amps, which is still 12 volts. So the current flowing through all of the potential difference across every resistor is the same. It's 12 volts. Okay, next question, the circuit current. When we talk about the circuit current, we're talking about the current that flows through the main wire. So in this case, the circuit current would be 6 amps. Why would it be 6 amps? Because look, here we figured out that there's 6 amps flowing through the resistor in series, and there's 2 amps and 4 amps flowing through each wire when it splits. So basically we can say that when these wires get connected, there's 6 amps current flowing through totally. And right now, and we know there's 6 amps current flowing through anyway, so we know there's 6 amps flowing through the main one, and we can add this to get 6 amps anyway. So the total current is 6 amps, but that's the circuit current. It does split at when the wires go in parallel, but the answer is 6 amps. We've done that. Next question, what's the total resistance? Okay, what is total resistance? So imagine that I took all these 3 resistors and I combined them into one resistor, which took in account all the resistance, all these 3 resistors, and so I only needed one resistor to represent them. What would its resistance be? In this case, we have to add all the resistance. But remember, when we add resistance in parallel, we have to add it in a different way to how we add it in series. So first, we'll add the parallel ones. So 1 over R2, 3 equals 1 over R2 plus 1 over R3. Okay, now 1 over R2, 3 is 1 over 6 ohms plus 1 over 3 ohms. But this we can write as 2 over 6 ohms. This is 3 over 6 ohms, which is half an ohm. Okay, now we can add this value, and now we can take this value, so 1 over resistance 2 over 3 is half an ohm. And remember, this is a very important thing. We can flip them over, so we get 2 ohms, we can multiply 2 on both sides, and then we can multiply this value on both sides, or we can just flip the reciprocals and we get 2 ohms equals R2 is the resistance of these two combined. So if there was one resistance in exchange of these two, its resistance would be 2 ohms. Now if we want the total resistance, we have to add this resistance as well, because now we're in series. Because now what we did is that we turned this parallel one into one series one. And now what we have to do to find the total current is just add these two. So total resistance equals 2 ohms plus 2 ohms of the parallel and 2 ohms of this resistor plus 2 ohms, which is 4 ohms. So if there was only one resistor, it would only have to be 4 ohms. That's done. Next question, voltage of the power source. Okay, firstly let's use Ohm's law to find the voltage at this resistor. Voltage equals current times resistance, so 6 times 2, so it's 12 volts going through here. Now, we know that voltage doesn't split in parallel, it only splits in series. So, what we can do is that we can use, from our last question, the combined resistor, the combined imagined resistor over here, right? And since voltage doesn't split in parallel, we know both are 12 volts. So we can just imagine one resistor over here with 12 volts. But we know that voltage splits in series. And so now we have a series circuit. So the voltage total would be the voltage of the 1 plus voltage over 2, 3. So if we take the voltage of 2, it doesn't matter. If you take the voltage of 3, it doesn't matter. Both of them are going to be the same because voltage doesn't split in a parallel circuit. So both are 12 anyway. So voltage 12, and then this is 12 anyway. So you can take this one, you can take this one, or you can use the combined one from our previous question. It doesn't matter. It's 12 plus 12, 24 volts. Okay. That's done. The voltage of the power source is 24 volts. So this is a 24 volt battery. Okay, now what's the potential difference across X and Y? Okay, next question. So let's imagine we have a 24 volt battery and all the volts start flowing in this direction. Now it doesn't really matter what direction you can choose. You can also make the current flow this direction and it doesn't matter, you're going to get the same answer. But for our sake, let's imagine the 24 volts starts here. Now this resistor takes up 12 volts, right? So after 12 volts are given here, we have 12 volts going through here. Now we know that voltage doesn't split in parallel, so we're going to have 12 volts going here and 12 volts going here. So at X, we're going to have 12 volts. Now this resistor uses 12 volts. So firstly, let's write that X is 12 volts. Now this resistor uses 12 volts, right? So you're going to end up with 0 volts over here. And since 12 volts went here, and this resistor also uses 12 volts, you're going to end up with 0 volts over here as well. 0, 0, 0, 0, 0, 0, 0, all the way to Y. So you're going to end up with 0 volts at Y. Boom. So what's the potential difference across X and Y? Calculate their difference. X minus Y, 12 minus 0, 12 volts. The potential difference across X and Y is 12. First question solved. Let's look at one more question and we'll end it off there. Question 2, a good look. Take a good look. Now, first question, current flowing in each resistor. I've purposely picked a harder question so that we can solve it together and make ourselves understand it more. First of all, what do? We name our resistors. Always name your resistors. That way it's so much more helpful. There's 2 and resistor 3. Okay, so we know that current splits in parallel circuits, but it remains the same in series, right? So we can say that here comes the current. It splits. It goes back to what it was. So 3 amps, 3 amps, 3 amps, 3 amps. It splits. We don't know how it splits, but it splits and then it comes back to 3 amps. 3 amps, 3 amps, 3 amps, 3 amps. So at resistor 1, the current will be 3 amps. So you have 3 amps current for current 1, which corresponds to resistor 1. Next question. This is where it gets hard because you don't know how the current will get divided. You don't know if 2 amps goes in here, 1 amp goes in here, or 2.5 amps go in here, or 0.5 amps go in here. So what do we do? Okay, so this is a cool trick. Remember this. So first of all, what you do is you combine these two resistors into one. So if I were to combine these two resistors, what would I do? 1 over R2, 3 equals 1 over R2 plus 1 over R3. Now 1 over R2 over 3 equals 1 over 12 plus 1 over 6 plus 1 over 6. Now what we can do here is that we write this as 2 over 12, which is 3 over 12, which is 1 over 4. So 1 over resistance 2, 3 equals 1 over 4. So resistance 2, 3, so the equivalent resistance, so if I was to imagine a resistor over here, it would be 4 ohms. Now, imagine these two resistors are gone and this is all I have. 3 amps, 3 amps, 3 amps, 3 amps, 3 amps, 3 amps, and 3 amps just goes, right? So you have 3 amps going through a 4 ohm resistor. So what's your voltage? Well, your voltage for 2 and 3, imagine that they're a combined resistor, is their current 2 and 3 multiplied by their resistance 2 and 3. Now we know their current, 3 amps, that's what the ammeter is telling us. So we add the 3 multiplied by the 4 ohms. 4 ohms, which is 12 volts. So there's 12 volts going through this. Now you may ask, what am I supposed to do with this 12 volts? Well, current doesn't remain the same for parallel, but voltage does. So now you know that there's 12 volts in this wire and 12 volts going through this wire. Okay, so if there's 12 volts going through this and it's a 12 ohm resistor, voltage equals current times resistance, we know it's a 12 volts going through, 12 volts going through, and it's a 12 ohm resistor. It's a 12 ohm resistor, so the current must be 1 amp. 1 amp. Wow, okay, let's do the same. Now we know that if there's 1 amp going through here, and there's a total of 3 amps, 2 amps must go through here. But if you still apply Ohm's law, and we do it, let's do it with Ohm's law. Let's apply Ohm's law over here. Same thing. Okay, what's our voltage? 12. What's our current? What's our current? We don't know. And what's our resistor? Resistance? 6 ohms. 6 ohms. What do we get? Divide both sides by 6. 2 amps. And so now we know that the current flowing through each resistor is, for the first one, it's 3 amps. For the second one, it's 1 amp. And for the third one, it's 2 amps. Boom. Okay, next question. What is the potential difference across each resistor? Okay, let's look at resistor 1. To calculate the potential difference, we use Ohm's law. Voltage 1 equals resistance 1 multiplied by current 1. We know the resistance, 6 ohms, and we know the current, 3 amps. 6 multiplied by 3, 18 volts. That's the first question done. And you know what's surprising? We've already found the potential difference for the other two. 12 volts, and this we know this is true because voltage doesn't split in parallel, so both are 12 volts, so voltage 2 equals voltage 3 equals 12 volts. There we go. These are the potential differences for each resistor. Next question, circuit current. That's the total current flowing through the entire circuit, so in these main wires without it splitting, and that's already provided. 3 amps. So C is 3 amps. Provided. Done. Okay, question D. What is the total resistance? So to calculate the total resistance, we first have to find the total resistance in parallel. And we've already done this, but let's do it again. 1 resistance 2 over 3 equals 1 over resistance 2 plus 1 over resistance 3. Now this what's the resistance of the second resistor? 12 volts. So 12 ohms. 1 over 12 plus 1 over 6. Now, we can rewrite this as 1 over 12 plus 2 over 6, which is 3 over 12, which is 1 over 4. 1 over 4. So 1 resistance 2, 3, so that's there, equals 1 over 4 ohms. So resistance 2, 3 equals 4 ohms. Now to calculate the total resistance, we also have to add this. So resistance total equals the resistor of resistance 1 plus the combined resistance of these two. So that's 6 plus 4, which is 10 ohms. So the answer to this is 10 ohms. Done. Now, next question. Okay, so now what's the voltage of the power source? So first we need to find the voltage across here, and then find the total voltage across here, and then we add those to get the voltage of the power source. Okay, so resistor 1, 6 ohms with 3 amps. So voltage 1 equals current 1 multiplied by resistance 1. So, well, our current 1 is 3 amps multiplied by 6 ohms, which is 18 volts. And we know here that voltage doesn't split in parallel, so 12 volts going through both of these. And so, since it doesn't split, we just take 12 volts. We know that. So voltage 2 and 3, you can take either, or they combined one, you're going to get 12 volts anyway. So, total voltage total, is voltage 1 plus voltage 2. Or instead of this, you can say voltage 3, or you can say voltage 2 or 2 and 3 combined. It doesn't really matter. So 18 plus 12, you're going to get, it doesn't really matter because you're going to get the same answer anyway, 30 volts. So voltage of the power source is 30 volts. So you have 30 volt battery over here. Last question. What is the potential difference between X and Y? First of all, let's locate X and Y. X is over here and Y is over here. Okay, so let's imagine that 30 volts go out from here this time. Last time we imagined that they go out from the negative side, but this time let's imagine that they go out from this side. Now, when we're talking about current flows from positive to negative, but when we're talking about electron flows from negative to positive. That's something to keep in mind. But no matter what direction you choose for where the 30 volt goes from, it doesn't matter because you're going to get the same answer anyway. Okay. 30 volts starts going through here, 30 volts here, 30 volts here. And we remembered that this takes up 18 volts because 3 amps multiplied by 6 ohms, 18 volts. Okay, so you take up 18 volts, you get 12 here, 12, 12, 12, 12, 12, 12, 12. Now, you have 12 volts at this point. Voltage does not split in parallel, so 12 volts go both. 12 volts, we know that this takes up 12 volts, so 0, 0, 0. 12 volts go. We know that this takes up 12 volts. So after this, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So 0, 0, 0, 0, 0 all the way. So at this point, we have 0. And at this point, we have 0. So the current at X, the voltage at X is 0. And the voltage at Y is 0. X minus Y, Y minus X, both are 0. And look, you're looking for the difference, so you should never get a negative number for this, right? So you always subtract the bigger number from the smaller. You always have the bigger number over here and the smaller number over here. So make sure it's never a negative number because you're looking at the difference. Either way, you're going to get 0 because both of them are equal this time. So the potential difference between X and Y is 0. Done. That was the 2 practice questions. Now, I suggest that you try some of your own practice questions. So hey, I hope you've all enjoyed the video and learned a lot, and if you have learned, I'm really happy. I'm going to try and put more videos on this topic, but I think we've covered most of the topic, most of the basics of the topic. I think, yeah, after this, I think it'll take a long time for me to upload anything electricity related, maybe something on like power, so voltage multiplied by current, I think. So yeah, I'll look into that and I might make a video on that, but I think this is it for like this series for quite a long time on the physics series. But if there is anything apart from electricity, I'll definitely be uploading that. I hope you've enjoyed this video and everything, and yeah, see you in the next one. Bye bye.